Good evening, algebra students. So for the past couple of days, we've worked just on one-step equations. Well, now it's time to up our antics and we're going to move on to two-step equations. So I'm sure you can guess they're going to take 2 steps in order to solve. So what I'd like for you to be able to do is to solve two-step equations, and remember to do that we're using inverse operations. So I'm going to highlight that up there because that's a big kind of piece of vocabulary for you. Inverse operations. Alrighty. So it says a two-step equation like 2x plus 3 equals 15, that's just an example, involves 2 operations. You can undo the operations by doing order of operations in reverse. So I'm going to write out PEMDAS. And what that means is when we're trying to solve for a variable, we're going to add and subtract first, then we'll do our multiplication and division, our exponents and our parentheses and grouping symbols. So we're going to start at the back and work our way to the front when we're solving. If we're just simplifying something, then you do PEMDAS the forwards way. But when we're solving and isolating a variable, that's when we do PEMDAS backwards. So here we have our first examples, and it says, what is the solution of 2x plus 3 is equal to 15? Well, the rules that we talked about a couple days ago, where whatever you do to one side of the equation, you do to the other, still applies. So I'm going to draw a line where my equal sign is, so you can see here's my left side and here's my right side. What I do to the left, I also need to do to the right. Well, what is my first step here? I'm going to do order of operations in reverse. Adding and subtracting is the first thing I should be looking for. Well, this says plus 3, so I'm going to subtract 3 to do the opposite of that. So minus 3 on the left, minus 3 on the right. Let's find what I get. Well, 3 minus 3 cancels on the left side, and I'm left with 2x. I have 2x is equal to, well, 15 minus 3 equals 12. Notice I still have a 2 with my x, so I'm not done solving this. I want x to be completely alone. So I'm going to now divide by 2. How did I know to divide? Well, remember, when a number is right next to a letter, it means multiplication, and the opposite of multiplication is division. So now these cancel, and I have x is equal to 12 divided by 2 is 6. It then says check your answer. The way you're going to check your answer is to take the answer that you got and substitute it back into your original problem and calculate it. So I have 2 times 6 plus 3 is equal to 15. Now we're going to start doing our order of operations. 2 times 6 is 12. And then 12 plus 3 is 15. And does 15 equal 15? Yes, yes it does. So we know we got the right solution. Okay, now we have another example over here. It says 5x minus 4 is equal to negative 29. Here's my equal sign. I'm going to draw a little line so I can see here's the left side of the equal and the right side of the equal. Now I want to do PEMDAS backwards. Do I have any addition or subtraction? Well, right here it says minus 4. So to do the opposite of subtracting 4, I need to add 4. So plus 4 and plus 4. Okay, those cancel on the left, and I have 5x left over is equal to negative 25. Once again, 5 right next to the x means 5 times x. So I need to divide to get rid of multiplication. Divide by 5, divide by 5. They cancel on the left, and I have x is equal to -5. We're going to go ahead and check our answer for this one as well. So you take your -5 and you substitute it back in for your x. So 5 times -5 minus 4 equals -29. Now we start doing our order of operations. 5 times -5 is -25 minus 4. -25 minus 4 is -29. And -29 equals -29, so we got the correct solution. All right, so both of these, the two steps were to either add or subtract something, then divide. In our next examples, we're not going to be dividing anymore, we're going to be multiplying. Notice that we have our variable in a fraction. So I'm going to write it down one more time because this is something that people always forget, so I'm just going to remind you. Fraction bar means division. Okay, so we have our equal sign right here, and we go to the left side because that's where our variable is, and I have a divided by 5 minus 18 is equal to 2. Well, what am I going to do first? Add 18 or multiply by 5? I need to do PEMDAS in reverse. So I'm going to add 18 first because adding is opposite of subtraction. So I'm doing the same thing to both sides of the equation. My 18's cancel and I have a over 5 is equal to 20. Now I have a divided by 5 is equal to 20. The opposite of dividing by 5 is multiplying by 5, so I'm going to multiply by 5 on the left, multiply 5 on the right. They cancel on the left, and I'm left with a is equal to 100. Okay, it says check your answer. Just like before, take this a and substitute it back into your original problem. So I have 100 divided by 5 minus 18 is equal to 2. 100 divided by 5 is 20. So I have 20 minus 18 is equal to 2. 20 minus 18 is 2, so 2 is equal to 2. That is correct. So I have the right solution. Looking over here, notice the variable's now on the right side of the equation. That's okay, we still solve it the same way. It's just now it's on the right side. So I'm going to draw a little line so we can see where my equal sign is. So 4 on the left is equal to f divided by 6 plus 10. You're going to work your way towards the variable is another way that I like to say it. So I'm going to subtract 10 from both sides first. Minus 10, minus 10. 4 minus 10 is negative 6. Carry down my equal sign is equal to what I have left over. I haven't done anything with this f over 6 yet, so I'm just carrying it down until I'm ready to use it. Now I have f divided by 6. Okay, the opposite of dividing by 6 is multiplying by 6. So I'm going to write that in. Whoops, I wrote 5, not 6. Multiply by 6. And multiply by 6. These now cancel. They go away basically. And I'm left with f on the right side, and 6 times negative 6 is negative 36. So there's my solution. What we're going to do is substitute it back in to check our answer and see if we got the right one. So my problem is 4 is equal to negative 36 over 6 plus 10. That gets me 4 is equal to, do order of operations. So negative 36 divided by 6 is negative 6 plus 10. I just keep carrying this 4 down because I'm not doing anything with it, but it doesn't go away. So keep writing everything that is in the problem. 4 is equal to 4, so we got the right answer. We're good to go. Okay. Our next two problems, we have a fraction in here, but notice that the addition and subtraction are not outside of the fraction bar anymore. So does that mean that we still add 7 to both sides first? Well, no, it does not, because if you remember way back from chapter 1, not only does a fraction bar mean division, a fraction bar is a grouping symbol. So I'm going to write that in as well. Fraction bar is a grouping symbol. Okay. So what that means is I can put parentheses around the tops of these equations. And if we look up here at PEMDAS, parentheses is the last thing that we worry about. Multiplication and division come before that because we're solving and we're doing this in reverse. So that's why we're not going to, in this example, that's why we're not going to add 7 to both sides first, because this is in parentheses, so we have to do that after our multiplication and division. So we have x plus 7 divided by 3 is equal to negative 12. You go to the side with the variable, and we have all of this stuff divided by 3. Well, we have to do the opposite of dividing by 3 in order to isolate the variable. The opposite of dividing is multiplying, so I'm going to multiply by 3 on the left and multiply by 3 on the right. These 3's now cancel, and I'm left with everything in the top. The top stays the same. I have x minus 7 is equal to negative 36. Now, x minus 7, I'm going to do the opposite of the minus, which is adding. So plus 7 plus 7. I have x is equal to negative 29, and that's my answer. Let's go ahead and check it and make sure we got the right thing. So I'm going to take this x equals negative 29 and stick it back in here into my original problem. So negative 29 is going in. Minus 7 over 3 is equal to negative 12. I'll put parentheses around it so you can see that. Negative 29 minus 7 is negative 36. So now I have negative 36 over 3 equals negative 12. And negative 36 divided by 3 is negative 12, so I have negative 12 is equal to negative 12. That's true, it works out. Looking at our next example, we have 6 is equal to z plus 10 over 9. Well, I went ahead and put parentheses around it like before, so there's two things that you need to be remembering with fraction bars. They mean division and they are grouping symbols. So everything on the top of the fraction stays together and everything on the bottom stays together as well. So I go to the side with the variable, which is the right side, and I have divided by 9 over here. The opposite of dividing by 9 is multiplying by 9. So I'm going to do that on the left and right sides. They cancel. Don't do anything to the top because this 9 is canceling with the bottom 9. So the top is staying the same. Okay? Now on the left, I have 9 times 6, which is 54. And then I carry down what I have left over on the right, which is z plus 10. I'm sticking on the side with my variable, and so I'm going to subtract 10 from both sides. The reason I'm subtracting 10 is because that's the opposite of adding 10, which is what I have in my problem. So 10 minus 10 cancels, and I'm left with z on the right. 54 minus 10 is 44. So that should be my solution. To check my work, I'm going to take this 44 and stick it back into my original problem. So I have 6 is equal to 44 plus 10 over 9. Well, I'll put parentheses around it. Do the top first. So that's going to be 6 is equal to 54 over 9. 54 divided by 9 is 6, so I get 6 is equal to 6, and my work is correct. Alrighty. We are moving on to the back of the page now. And here it says solving with negative variables. Do not let these negative signs get you mixed up. Remember, there is an invisible 1 when you can't see it. So we're going to be implementing that in these problems. What I want you to first do is do PEMDAS in reverse. So I have negative t minus 8 is equal to negative 3. First, I'm going to get rid of that negative 8, or sorry, minus 8. So the opposite of subtracting 8 is adding 8. I still have a negative in front of this t, so I'm just going to carry that whole thing down. I have negative t is equal to 5. Now, remember that there is a 1 in front of this. It's invisible, but there is an invisible negative 1 there. So this is negative 1 times t. Well, the opposite of multiplication is division. So I'm going to divide by negative 1 on both sides of the equation, and that's what's going to get me to cancel those out. I'm left with t is equal to negative 5. All right, we're going to check our answer now. So I'm going to take negative 5 and stick it in here for t. So I have negative 5 minus 8 is equal to negative 3. Well, the negative of a negative becomes plus a positive. So now I have 5 minus 8 is equal to negative 3. And that's going to get me negative 3 is equal to negative 3, and that is true. All right, looking at our next one. We have 14 minus d is equal to 19. The minus d is important. When you see a minus sign, that actually means negative. They're minus and negative are just about interchangeable in math. So when we move this 14 to the other side, don't lose your minus sign. This is a positive 14. The opposite of positive 14 or plus 14 is minus 14. So I'm going to subtract 14 from the left side of the equal sign and subtract 14 from the right side of the equal sign. They cancel, and I'm left with negative d is equal to 5. Okay, remember, just like over here with the t, there's an invisible 1 here. So to get rid of that negative 1, I'm going to divide by negative 1 on both sides. And I'm going to get d is equal to negative 5. We can plug that in. So I have 14 minus negative 5 is equal to 19. Well, minusing a negative becomes plus a positive. So now I have 14 plus 5, getting me 19 is equal to 19. And so my work is correct. We're almost done. I'm giving you lots of examples, so hopefully it helps you and you understand the steps that you need to take to isolate your variable. For problem 5, it says writing your own examples. So I'm going to show you a couple, but it would be great if you tried to do it on your own just to see if you can come up with something. It says, write an equation that has a fraction and a negative variable in it. So it doesn't matter what the solution is or really what it looks like. All we need is for it to be an equation, for it to have a fraction and a negative variable. That's all we need. So I'm going to say that 21 is equal to, I'm going to go ahead and put my fraction in there. So just come up with any fraction. 6/7. And then it says I need a negative variable, so minus x. I'll do one more for you. I'm going to put my fraction in. Let's make it 5/4. I'll put in my negative variable, minus 2s is equal to, and I can make it equal to a negative number as well, such as -1. So there are thousands, an infinite amount of answers that you could do this, or that would be correct for this. You just need to have a fraction and a negative variable in it, and it needs to be an equation. The next one, it says, write an equation that would require subtraction and division to solve. So if you're using subtraction and division, that does not mean that subtraction and division is in the problem. If you use subtraction and division to solve, then the problem will have addition and multiplication. Because remember, when we're solving, we do the opposite of what we see to isolate the variable. So our problem needs to have addition and multiplication in order to subtract and divide to solve. So once again, I'm just going to start making something up. 0 is equal to, and I'm going to have to make sure division and subtraction are required for it. So I have multiplication and addition in my problem. So I'm going to say 5 plus 2x. So here's my addition, and 2x is multiplication. I'll do one more. Let's see here. -8 m plus 40 is equal to 1. Both of these are possible answers. It'd be great if you come up with one on your own as well. All right, we have our very last problem. Solving a word problem, your favorite, I'm sure. It says there were 6 groups of kids on a field trip and 9 chaperones. If there were 33 total people on the trip, then how many kids were in each group? Okay, this last part of this sentence is letting us know what our variable is. How many kids were in each group? That's what we're trying to figure out. So let's start setting up our equation. It says there were 6 groups of kids. Well, let's write that 6 down. 6 groups of kids, and our question is how many kids were in each group. So 6 with X amount of kids in them. There were X kids in 6 groups, so it's going to be 6X. So that took care of the 6th group of kids, and 9 chaperones. So we are going to add 9 more people. So 6x plus 9 is equal to, and then it says if there were 33 total people on the trip. So the kids plus the chaperones is going to get me 33 total. Now I have my equation and I'm ready to start solving. I'm going to subtract 9 first from both sides. And I have 6x is equal to 24. Then I'm going to divide by 6 on both sides, and I get x is equal to 4, which means there are 4 kids in each group. All right, this is the end of notes for today. If you have questions, then I'll be able to answer them tomorrow, and we'll be practicing on this for 2 more days.